All right, welcome everyone. Today we are having our first webinar. This is going to be a series of webinars organized by the International Chamber of Mines of Armenia, ICMA, which is a relatively recently created organization. ICMA is a non-profit organization incorporated last year, June 2023. And our purpose is to elevate and enhance the competitiveness of the mining industry and the key mining companies in the relevant sector of the Republic of Armenia, and introduce the best practices in terms of sustainable and responsible mining, and of course adhering the highest ESG standards in Armenia. This organization was co-founded by Canadian Armenians, Armenian Armenians, and Lebanese Armenians. And we recently formed our board, and which you can see on our website. So today we are having our first webinar, and the topic of the webinar is not your grandfather's mining industry anymore: technology trends in today's mining and metals industry. Our first speaker is going to be Sevan Bedrossian. Sevan is the Director of Technology Development, Hydrometallurgy, and a Process Specialist at Hatch, which is a global engineering firm based in Canada. Sevan has over 20 years of experience in the field of hydrometallurgy and extractive metallurgy. He is skilled in developing novel process technologies and solving complex problems in base metals refining, critical minerals, and metals. Today, Sevan will be covering the recent technologies in mining and metals industry, and this talk will introduce some of the trends in today's global mining and metals refining industry. So about the housekeeping rules. So I see we are having new guests, so welcome, Gore. About the housekeeping rules, the presentation itself will last about 40-45 minutes maximum, and then we will open the floor for the questions. So if you could have questions, please type your questions in the chat, and then you will have the opportunity after Sevan finishes his presentation to ask your questions. So we can start. Thank you, Sevan, for volunteering to be our inaugural speaker. And I hope this webinar series will contribute to the purpose and mission of our organization. Sevan, you are on mute. Sevan, I'm sorry, you are on mute.
It's better. Okay, share screen. Yeah, I don't know why it doesn't go on a kind of presentation mode. Okay, I'm just going to use it the same thing if you don't mind. Okay. Admit somebody else. Okay. Hopefully all you can see my presentation. I'm just trying to put it on a kind of F1 mode. Okay, this is much better. So first of all, thanks very much, Artyom, and thanks very much the board that giving me this opportunity to kickstart the 2024 webinar series under ICMA. And thanks very much for everybody kind of joining this webinar. I know it's Friday evening in Armenia, and perhaps there is much better things to do. And the fact that you guys decided to join this talk, it's very much appreciated. Always, uh, the good lawyers kind of suggest that I put a disclaimer at the front of my presentation. I'm going to let you to read through this, but the bottom line is this presentation is the sole opinion of myself as a presenter, not ICMA, not my employer. And of course, during the presentation, I'm using lots of name as a company's name and referring to their works. I'm not endorsing them, but I thought by putting their names, going to give you an extra reference point that if you are interested about their technology, you can follow up and use the information. So if you're at my age, early 50s, and you live in one of North American cities, you very quickly recognize what's on the left side of the screen. It's a map booklet. I used to carry one of these map booklets in my car to navigate around the cities. This is during the good old days. I remember in 1998, as a young engineer, I was asked to kind of go to my first job interview. And I used one of these books in order to find my address, where to go. Of course, I was very nervous. So when I tried to navigate using one of these books, instead of taking the east side of that street, which is a long street called Bloor Street, it's almost 25 kilometers, I ended up on a west side of that. So I ended up in a wrong place. I ended up parking my car and finding a phone booth, a public phone, because I didn't carry a cell phone. In 1998, not many people had cell phones. So I ended up calling that interviewer, and he was very kind enough to kind of recognize that I made a mistake and gave me a good direction. So I ended up going back to the right place almost an hour and a half later. Of course, as you can guess, I didn't get the job. Nowadays, we navigate ourselves using our cell phones very easily. We take advantage of data and information collected in order to not similar mistakes and optimize our movements. If you consider the act of driving in both cases, in 1998 and 2024, it's no difference. You're driving the same car. But by taking advantage of data, you are optimizing yourself and increasing your productivity. This is the same theme that I would like to talk today during my presentation. But before I kind of go further, I would like to kind of mention about what are the forces that influencing mining today. One of the major forces that if influencing mining is increase in metals demand. Of course, as we are shifting from fossil fuel to clean energy and replacing oil with electrification, this all is required stuff. This stuff is going to come from mining as nowhere else. And that's why the mining is more important today for changing this dimension, the way we are living, than even before. So we'll see lots of demand in mining materials. The price is a different story. I'm not going to talk about the price because we see the prices fluctuate, but the demand is always increasing. Decline ore body grades. We see in the last centuries, we dig up everything that is good stuff. What we left with the low grade ores. We see in major mines, the ore grade is declining. And not only the ore grade declining, but also the complexity of this ore body is increasing. The impurity is increasing. I'm going to talk about those two, decline of ore body grades and impurities more specifically through the presentation. Product quality. Nowadays, people want to use the mining materials in battery production. In my daily kind of job at Hatch as an engineer, I can witness that people coming in with the demand of, very high quality product requirements. We are talking about 99.99% purity of, for example, nickel sulfates, cobalt sulfate that has to be used in a batteries. ESG is a front and center of all the activities nowadays. Thanks to kind of spreading technologies and fast tracking newses, nowadays we see the ESG is no longer, it's a story between a mining company, a local community, and regional government. There is a fourth pillar just joined to this whole conversation, and that's end user. The end users would like to know where this material is coming in their products. For example, the cobalt in a cell phone is associated with the child labor or not? So ESG nowadays, it's a part of the business. Speed to market, we used to build products and projects for our clients in a matter of 10 years, 15 years time. Nowadays, everybody wants to make their processes and their project in a matter of 3 or 5 years. So everything is speeding up and everything would be kind of built very fast. Digitalization and Industry 4.0, this is beyond mining. The whole industry as a whole, we go through the Industrial Revolution 4.0. The first one happened when we harnessed the steam power. The second revolution happens when we start doing a mass production. And the third revolution when we are adopting computers and electronics. But in the last 15 years, we're walking into digitalization revolution when we are taking advantage of data in our daily life and in industry, and mining is part of it. So I decided, being kind of a Friday evening, everybody wants to be chill out and relax. I thought just tell you 2 stories of my own, based on my own experience going through some of this works. This is going to be break it down in 2 chapters. The first one is about geosensing and geometallurgy. So be relaxed. This is not going to be too much of technical talk, but I thought maybe just keep it as light as possible, but informative. So the story started between 2003 and 2011. If you remember, at the time, the price of almost everything was going up very, very kind of, I can just move this. Price of, the commodities was going up drastically. Of course, I'm not talking about 2008 in between 2003 and 11, which is North America's financial crisis, but the trend was upwards. But after 2011, we witnessed that the prices start coming down. The major industries like China, which is used to driving the commodity prices, starting slowing down. That decrease in the prices put lots of stress on some of the big mining companies such BHP, Anglo American, and others, that they were doing mining with the low-grade ores, but the high prices that could have sustained. But no longer that was the reality. So in a quest of solving this problem, some countries and even some governments that try to step in to kind of assist this big companies in their quest of finding solutions. And one of them, the government of Australia, putting together a coalition called CRCO. While being led by Australians, other international players also joined, including from Canada. At the time, I used to leading the mining program for the government of Canada under National Research Council. So our team, which is around 40 and 50 researchers, they came up with some ideas and we joined the coalition. Before I'm moving on from this slide, I would like to kind of bring your attention to the slide on the right-hand side. You can see the trend, how the trend of the ore bodies and decline of ore grades reported here for Chilean mines. Of course, the solid line represents the grade decline, in average grade decline in all of the Chilean mines, and the one on a dashed line on top, it shows the decline of grade in a major one. And definition of the major one, it's down, such as Escondida and some of the well-known operations in Chile. But again, if you notice it, I can roughly tell you that today's mine grades, it's almost the half of the grades around the 1990s. In fact, in some cases, people start looking in their tailings. Some of the tailings is now richer than the mine itself. So before we're getting ahead, I just want to bring everybody on board and say, what's the typical mining production look like, or life cycle? It's all started from left side of this graph, when the exploration happened, and after the exploration, you discover your resources. Of course, not all the resource is amenable or feasible to production, and just a portion of that which is turned to your reserve can be uh, can be by, economically extracted and turn out to be profit. Of course, the planners come and plan that reserve, and they start chopping that and organizing that in the kind of blocks. Some blocks are good. It means they're at the grade that can feasible or above, or some of them it's under that grade or below grade and they're not feasible, so they're being discarded. During the planning also comes up comes to the plan that how we are going to extract it. During the extraction, the drill holes being uh, uh, drilled, the holes being drilled for blasting, explosive being charged in these drill holes, and the blasting happens. So materials on a bench being loose enough that can be extracted and going forward. I just admit I read. And materials flowing back basically to the mill, being processed, concentrate being produced, and the materials being discarded is being wasted and being piled. So the question comes, and again, as part of our work during with the Australian teams, we start thinking how we can increase the productivity. You can increase productivity by introducing productivity to your refining process. Well, that's good, but it's not good enough. We can bring the productivity to your mill operation. Well, that's much better. But if you bring your productivity right at the phase of extraction, perhaps you're going to get the biggest impact possible. Biggest impact both on financially by not moving material which is not needed, but also creating less waste or less processed waste and contributing to your environmental issues. For that very reason, we decided, and the team decided, go back and look at the whole process. And we realized that beyond the point of the planning, which is defining your block model, there are places that we can increase the resolution of understanding about our body better, taking advantage of the information, and bring some productivity to the rest of the process. If we look at, for example, a typical block planned by our mining engineers, we can see there, for example, in the block on the left-hand side, it's average grade of 1.25. If we start looking these blocks, which is based on information received during the extraction and drill cores and drilling, but if we can start looking more in a higher resolution, we can see these blocks or some of these typical blocks is actually comprises on a smaller blocks or smaller regions that some of them are low grade and some of them actually high grade. So this is what called ore body heterogeneity. It means the ore or your value composition, it's not equally distributed everywhere. And if you can take advantage, you can better understand your ore body, you can take advantage of that and increase the productivity. But the questions comes, how we can do that? So we kind of defined 5 pillars, and we said, let's work around these 5 pillars as a kind of a very practical solution. Things that is not necessarily very futuristic, things that we can implement it in a process. In fact, the theme of this whole work that we started with this Australian group from 2010 to 2020, it's about finding technologies that can be implemented, not the fundamental research. So the technology I'm going to talk here, perhaps you're going to even recognize it. Those are not new. The things is new, how we can connect all these 5 pillars together and take advantage and infuse them with the extra information or data. One of the first pillars that I'm going to talk about, preferential grade deportment size, differential blasting, sensor-based sorting, and in both sense of bulk and the stream sorting, and coarse gravity. I left coarse gravity out of today's talk because of the time constraint. What's the preferential grade deportment? Very simple. In some geological settings, not all of them, but in some of them, when you're blasting or you're crushing something, or naturally, the breakages happens around your value minerals. It means minerals usually deport themselves in a finer fractions. The graph on the right-hand side, you see in one of the mines, in the copper mines, you can see how the deportment of the copper, it's in a different sample fractions. If you can take advantage of this natural phenomenon, in some cases you enhance this situation, you can simply use screening, simple screening, as a way of concentrating your material. However, in order to understand the degree of preferential grading, we need to understand our ore body beyond just our block model, or rely on just the drilling cores. One of the techniques that it's nowadays being used is use of the hyperspectral imaging or things similar to that. What you can see on this screen, it's a sample of that. Hyperspectral we can use in order to screen or scan your bench wall or your bench floor using the light at the wave of invisible to naked eye light, in order to better understand the distribution of the ore bodies within the bench. And after that, combine them with your previously extracted information, and we better understand the ore body in higher resolution. And other techniques that being developed by CSIRO, this is Australian National Laboratory. It works based on a PGNAA, or prompt gamma neutron activation analysis. You can see on the right-hand side, this probe is like a small torpedo that you can lower down in your blast hole and get extra information about the materials around your blast hole. Just imagine you're taking advantage of this hole already there for blasting. Why not extracting the information and take advantage of that? On the left-hand side, there's another company which is using the same basis. In fact, they're working with the CSIRO to develop the commercial version of that called Southern. It's a French company. And all these probes nowadays is being used in Chilean mines to extract the information. That information can be input in a model that helps how the blasting is going to work. So when you blast your materials, now you have to understand, okay, so I understand, so what we learned so far, the preferential breakage, we understand that that's going to happen. We want to enhance it. There are techniques, and I put on a screen a few of them, that you can get extra information to have an understanding, a high resolution about your ore body. But how we can, after blasting, follow our materials to sort them out, to understand which one is still is amenable to a feasible extraction or not. There are other technologies such as radio frequency identification, or RFID tags by Metso, that you can, when before the blasting, you can introduce them in your blast hole. Those are very small, very cheap tags, very similar to tags actually you can find in any mall attached to some of the clothings when they're selling that, or at high price electronics, people not taking out of the store by mistake. Those are very passive tags or sensors that they can withstand the blast force. They can go all the way through your crushing, and they can even pass through your crushing. So you can follow materials for that section just using kind of RFID tags going forward. So all of this information, it's ready to be used by blast engineer. Now come to differential blasting. Again, goes back to what I said. The preferential breakages can be enhanced if we understand our ore body. If we understand our ore body, that information can plug it in a simulation, which it does exist. And blast engineers comes and start loading these blast holes by by different type of explosive, by different type of loading. They control the timing and even the spacing between the blast holes. They can enhance this preferential blasting. So in areas that you have more high-grade materials, they're turning to that fine, and the areas that they don't have much of the high-grade materials, you can break it in a bigger chunks that when pass the whole materials through the screening, naturally you can do a very easy and very cheap way of kind of concentrating your material, lowering down the energy that you need in your comminution circuit, in uh, in your crushing and grinding, and cutting cost, and again cutting on environmental footprint. So you blasted your site. Now you have, based on all we learned so far, now you can want, there are other techniques that even pushing this further. For example, there are sensors nowadays built by a company called MineSense that it can be attached to your shovels. Every shovel that you extract after your blasting now can be screened using, for example, XRF sensors. And you can realize if that shovel is under the grade or above the grade material. Should put that shovel size materials in a truck that goes to the dump or goes to the my milling process. You further taking advantage of this sensors and technology in order to segregate what is good, what is not good for this. And this sensors is using XRF technique. For example, and those are, again, I just keep emphasizing, those are not techniques that is very futuristic. This is technique, it's implemented, it's being used. For example, in this case, you see this data, which is I extracted directly from the MineSense website. It's being used for in a copper mines, in Copper Mountain mine in British Columbia, Canada. The picture on the left-hand side is your mine plan based on your drill course data. But when start extracting, the shovel sensor start identifying a rich areas before that those didn't identify before in a mine plan. You can see on the picture on the right hand, you see this rich mine. So at the shovel level, the decision came out that no, those materials actually is not a waste. They can be processed, and they increase the productivity. I really encourage that you look at some of this website and for yourself and get better familiar with this technique. Of course, the materials can be also subject of sorting on a sensor based on a belt. That's another bulk technique to sort material. This is where actually my team at the National Research Council got involved. We started developing a sensor based on a laser base called LIBS. I didn't include it here because it hasn't been commercialized. Some patent issues still standing around that one, so I didn't include it in my presentation. But very similar to that one, but not based on a laser, but based on a prompt gamma neutron activation analysis by Scantech, nowadays being used. The Joe scanner or Joe Scan M that you can see the picture of that on the left-hand side easily can detect the copper grade as a resolution of the 0.202%. Sorry, 0.02%. Of course, there's a delay because of the technique for 30 seconds, but if you can adjust your process of, let's say, decision making on a belt within 30 seconds, now you have a good understanding if the materials on a belt has to go to the waste dump or again for production as a kind of sorting. Again, I explain about how we can take advantage of the size as a kind of basis for deportment of high grade versus low grade and going to screening. You can see what you see on a screen is a bulk sorting using just simple screening. Of course, the sorting can push even at the particle size using what we call particle sorting. You can see an example of here by Tomra. Tomra provides some sorting equipment that using X-ray transmission or XRT in order to sort materials again, based on a grade, based on a composition. So in a conclusion, mines are getting smarter. Some of the techniques that I taught today is going back to the same story that I started my presentation. The issue of getting late on a presentation just using map versus nowadays using the GPS. The, the, the act of driving, as I said, it's no difference between those 2 years. Is advantage. The point is taking advantage of data. And today's mine are moving towards that. Is taking advantage of data in order to increase productivity. There are lots of other techniques or technologies. It's being used nowadays in the mining. I didn't talk about some of them. For example, variables by mine operators, autonomous vehicles, electrification rather than using fuels, and all those things is other techniques that perhaps is an opportunity maybe during the next webinar we can talk. Of course, I want to tell another story. I put it in chapter 2 called Copper Slimes Refining. I thought I'm a hydrometallurgist. I cannot go through this presentation not advertising hydrometallurgy. I love this area. This is what I do on a daily basis. And of course, I thought copper maybe it's something, it's a theme that it can be attractive to the audience of today. So I consider this story, which is again, I'm personally involved during the last 10 years, called Copper Slimes Refining. The picture, the beautiful picture you see, it's this amazing picture by Paul Warren, is an open pit copper gold mine in Indonesia called Grasberg. Perhaps some of you heard about that. Is one of the biggest copper production, and in fact, one of the gold production in the world. In 2009, government of Indonesia came to this conclusion that we are going to stop sending our concentrate out. It's better to kind of ban shipping of the concentrate and refining that within country, which is wealth creation, job creation. So they turn around to their partners, because most of the mines in Indonesia is a partnership between private sectors and the government. In this case, they turn around and told the Freeport, which is an American mining company, and they told them, listen, you cannot take the concentrate out anymore. It has to be processed inside the country. Of course, that ban has been pushed back and pushed back because of the COVID, because of some technical things, but right now there's good advancements happening. The smelter is being built, and also the slimes portion of that. I'm going to talk about that later on. Again, if you're not familiar with copper smelting, everything starts from producing concentrate. Concentrate goes through the flash smelter furnace, converted, and after that turned to anode furnace. Anode being produced. Anodes are impure coppers as you can see in the picture. They go through the refining, which is electro refining, and turn out to refined copper. All the other goodies, including gold and silver, also at this point report to the slimes portion of this electro refining, and they collect it and send it to slime treatment plant. You can see on left-hand side a typical electro refining operation for copper. As I mentioned, after turning copper from anode to cathode materials, all the precious metals reporting to the slime portion, alongside with some of what we call as impurities, and most important, arsenic and bismuth. In case of Grasberg, there was one problem. And going back to what early on I said, not only the grades of the ore bodies is declining in major mines along, around the world, but the complexity is increasing. In case of Grasberg, the plan is actually the mine goes deeper and deeper and goes to perhaps underground. By going underground, some impurities such as bismuth and arsenic is increasing drastically. For that very reason, and they're deporting to the slime portion of that. For that very reason, the pyrometallurgical route of extracting gold, which you can see on the left block flow diagram of this presentation, is no longer viable, because as soon as the slime goes through this process and reach to Dore furnace, which you can see in the middle, the slag has to go back to the smelter, but slag is going to carry lots of bismuth and arsenic. And the accumulation of this material cannot withstand the whole operation. So the hydrometallurgical route being kind of assessed and kind of implemented in this case, which is started, you can see block flow diagram of that on the right-hand side, which start from copper and tellurium removal, and the gold being leached through the wet chlorination. The soluble gold report to gold solvent extraction, while the silver and the lead, which is not being leached, it goes to the different portion you can see here. It goes to the ammonia leach, where the lead and silver being separated from each other. The point I'm Vartkes, if you don't mind, just put your connection on mute, Vartkes. Yeah. So, yeah, I mean, the point, I don't want to go through the detail of technical things, but I just want to say one of the trends we see in today's mining, take advantage of hydrometallurgical routes. Hydrometallurgical processes tends to be more flexible, taking care of impurities than conventional pyrometallurgical. And you see there is lots of areas in the processing that people, which is used to be pyrometallurgical processes, now people start considering hydrometallurgical processes going forward. As I mentioned, I talked about the sludge refining. I purposely didn't talk about opportunities taking advantage of hydrometallurgy in copper processing, which is, I think, it's very important area. My colleague of mine and good friend of mine, Vigen Abrahamian, and myself, which is actually present during this presentation, we did in a few years back, we did a presentation on this very subject. And I think it's worthy of having its own subject going forward. I think this is going to be very interesting, especially for application in Armenia. What's the conclusion here today? I talk about lots of technologies. I talk about lots of processes. You may not remember any of them, being a Friday afternoon. I'm going to leave you as a conclusion by showing those two pictures. What you see on the left-hand side and what you see on the right-hand side is almost those two. The group of people is doing the same thing that the person doing on the right-hand side. The person on the right-hand side is sitting in a confined, comfortable room doing a drilling in one of the mines in Sweden. Take advantage of technologies which is mostly driven by data collection. He's doing almost the same thing. He's using a jumbo drill underground, drilling the same thing that other guys, group of people is doing right there. But he's doing more efficiently, it's safer, perhaps leaving less waste around it because of the better control. So this is what the mines of today's look like. This is just one example of that. It came a long way. Today's mine is really not your grandfather's mine anymore. It's not even your father's mine anymore. There's lots of good things happening. And the technologies I talk, again, those are things being implemented. All of the technology I touched today, it's being used either somewhere in the world right now and the commercial side. There's a lot more coming in a pipeline of technologies that I haven't even talked about that one. That's part of my daily job. Look at after some of this technology, assess them, and find an end user for that. I just want to thank you very much for everybody kind of attended today's webinar. And I look forward to answering if there are questions or opinions. I would more than happy to return the mic to you, Artyom, and finish my presentation at this point.
Thank you. Thank you very much, Sevan, for this extremely interesting presentation. And I believe, you know, most of your points have a very big practical value also for Armenia and Armenian mining industry players. And yes, let's open up the floor for questions. Are there any questions, colleagues, that you would like to ask Sevan?
Can I jump in with a question?
Yes, please, Mr. Gasparian. Hello and welcome. Yes.
Oh, guys. Hi, how are you? Sevan, thank you very much. I loved your presentation. It's really exciting, the directions. Couple of questions. One is these viable, feasible technologies, they still need to go through corporate adoption decision-making process. What are some of the barriers? So what would you think would be the barriers in Armenia, for instance, for companies to adopt them?
I guess it's start from early on from webinar like this. First of all, you have to know about these technologies out there, right? I guess the first thing is come to point of information. There's a whole host of, technologies out there can be adopted. All of this technology, in fact, I kind of brought it up and gave an example. All of them being used mostly in the copper and gold mines. I selectively chosen some of these technologies, considering the geology of the Armenia, and as long as I know, to be kind of applicable. For the first thing is information. You have to know what's out there in order to take advantage of that. The second thing is it's a group of people within corporate or outside of corporate that can rely to assess some of things, see if it's amenable to your geology. I very clearly mentioned that, for example, preferential breakages is amenable to some geological setting, not all of them. So you have to know, you have to assess, both on the financial and technology part, and you can kind of adopt it. I guess that 2 point is very important for any corporate decision. I can see in my daily work that people comes to us and said, can you find the technology, assess for us, both on the technical side and financial, and we are going to make a decision on that basis.
And I just a quick follow-up question. Do you think it makes sense for an organization like ICMA to say we're going to do a technology as a pro bono or maybe a research, capacity building activity, a technology audit of mining companies in Armenia, and find out where the gaps are, where the industry is behind, where maybe it's advanced. I mean, we know some cases where local industry was actually globally advanced in like the Albion process and so on and so forth. So yeah, so is there a role for ICMA to do this kind of industry research, if you will, or anyone? Would that, you think, will be a good, not exactly second next step, but next step of sorts?
I'm going to leave Artyom perhaps answer this question. It's kind of on behalf of ICMA.
Yeah, thank you, Alan, very much for this question. Basically, as you mentioned, that potentially can be the next step, because as I said, we are like a recently created organization. But I think we have to bring in all the stakeholders in the mining industry, and this is why our purpose to build stronger relationship with the government is very important. So yes, and I bearing in mind our international network and having ICMA is not a local organization. Our founders, it's an international organization, and thereby I think we are very well positioned to source international technologies and the modern trends in the mining industry. And as one of our co-founders, Srab, always mentions, it's twofold. So first of all, it's from outside to inside, from the international environment to Armenia. And then, when we create competitive industry with, applying modern technologies, then Armenia will be in a position to supply its fair share of critical minerals for the green energy transition. And I will ask if our colleagues from ICMA, if they have anything to add to expand more on this question, please go ahead. All right, any other questions?
I just want to quickly add, Artyom, this is Rob here, Terry, that a lot of companies are always striving for more recovery, lower costs, margins. This technology, as Sevan said, it's been around for a while, and it's very transferable. It's available in the business. there's no propriety by anybody in terms of the technology. There's licensing. One is that these are common.
So Rob, I think your connection is not. Rob, we can't hear you.
Let me put my headphone on just a second. All right. Okay. I'm doing better now.
Let's give it a try, maybe.
As Sevan is suggesting, all these technologies have been around for a while, and there are owners of technology, adoption licensing issues. But every company essentially strives for better recoveries, more margins, lower costs, and these are quite widely available. So in essence, if the company is profit oriented, if the company is efficient, and this is something that we can consider talking about this, but I think it's up to the enterprise and the company themselves to decide how much money they're going to spend, because these are some capital intensive issues as well. But nevertheless, maybe that's an overall policy issue. When we say sustainable mining, also means best mining practices that they should be considered in the investment process. But again, these technologies are not around. They've been around for a while. It's all ahead. If you go to any trade show, more and more coming along. And another thing I will say is that, as Sevan showed on.
Yes, so Rob, I'm sorry, I have to interrupt you because you can hear me? Because of your connection, I don't think we can listen to what you are saying, but I think at least we caught like about 70% of what you are saying, which is still very valuable, and it responds to Alan's questions. And colleagues, any other questions that you'd like to ask Sevan or ICMA representatives?
Artyom, may I come in?
Yes, sure,
Yeah.
Irina, please, welcome.
Thank you, and I apologize, I'm driving, so I'll turn off the video. First of all, thanks so much, Sevan, very interesting presentation. I come from the World Bank, and currently we're assisting the government of Armenia in developing green taxonomy. So I was curious whether in the countries where these technologies have been adopted, this has been considered as BAT, best available technologies. And in green taxonomy draft that we have proposed to the government, there is chapter on mining, and we have enabling and transitionary activities where adoption of similar technologies is considered. So just curious to know the extent to which these sets of technologies have been adopted as BATs in countries where this has been already in practice. Thank you.
So this technology is being adopted in individual mines. So I cannot give a comments, Irina, from point of view of a country or a national organization. But all of this technology that as I said, kind of pointed out, and Srab kind of alluded to, they are not entirely new. They already kind of passed, or they are at the commercial kind of adoption. So they are not fundamental research or piloting. And there are studies that clearly indicate their benefits of adoptions. Again, some of these studies I cannot personally verify because put out there either by mining company themselves or the technology provider, but there are lots of evidence out there that can explore that's what of the the benefit of this technology. And again, just going back, these technologies are adoptable or incorporated on a case-by-case basis. I mean, in your geology has to be amenable to take advantage of some of this technology. So it's not to say because in Chilean mine they adopted, I can adopt it because I don't know if my geology or your geology is the same as the other geology. So there's a level of kind of studies has to happen in order to see. But again, just I purposely didn't pick technologies that they are in the process of piloting or research. Those are well, to some degree, they're well-established technologies. Hopefully that answers your question, Irina.
Thank you very much, Sevan. And if possible, if you could share the presentation with us, I'd love to consult our colleagues to see if we have included this or not, and if whether we could possibly include it in the list of BATs. Thank you.
Yes. Thank you, Sevan, very much. Unless there are other questions, I would like to sum up this presentation, thanking Sevan very much for being our first inaugural speaker. The purpose of this platform and this initiative to have ICMA webinars is to create this space of experts, specialists, and stakeholders who are interested and who are passionate about bringing in the best technology in the mining sector into Armenia, complying the highest ESG standards. And please, if you have any comments, any suggestions, for example, Irina, what you mentioned is very important and very interesting to us. I'm referring to the report that you recently filed with the government. And I'm sure we would like to hear, all of our colleagues would like to learn more about that report, and perhaps there might be angles around which we could collaborate together. So thank you everyone for your participation. And unless there are any questions, I would like to close. The next webinar most probably is going to be in a month time from now. Our purpose is to hold regular monthly webinars, and we will send the announcements. And please contribute, make your suggestions and ideas. And if you think that anything has to be improved, the way we are organizing our works, please, you are welcome, and we are always available to consider and implement your suggestions. Thank you very much. Thank you, everyone.
Thank you.
Thank you very much, everyone. Bye-bye.
Thank you.
Thank
Bye.
you, everybody.
Thank you, Sevan. Thank
you.
you.